Is there anyone here who is not familiar with the following scenario? You've recently released a new machine learning project to production, and you're excited to start working on your next project. Suddenly, sometime later, maybe a few hours, days, or weeks, you understand that there is some problem. What exactly is the problem? Well, this is your story, not mine, but I can share with you that in the 7 years since I've transitioned from cybersecurity to machine learning, I've discovered that there's a wide variety of problems that these types of models can face. One thing I'd want to ask you, though, is what is in common with these types of different challenges? So one thing I find in common is that these are all a major challenge in adoption of machine learning systems, the ability to be able to trust them and to make sure that they work properly in real life and on real data. However, another challenge in machine learning, which I know and now you do as well, is that many of these issues can be identified and mitigated offline. This is one of the things that we've discovered in Deepchecks when monitoring lots of machine learning systems in production, and when actually helping to analyze and find the root causes of the different problems, we understood that many of them could have already been discovered before. So this leads me to the topic of our talk, which is validating your machine learning models and data. Hopefully, if you adopt these processes, you'll be more in the bottom scenario and less in the top one. The thing is that there isn't a specific magic solution for this, right? It really depends on your data, the domain, the stakeholders, and the sensitivity of your model. So my targets here is to both raise the awareness and give the various examples of the things you might want to check and be aware of, and also to give some methods and tools and ideas of how to actually do it. So I'd like to share with you a short story, which is actually one of my first machine learning projects that I was working on. We tried to classify for a group of people whether they would do a specific action or not. And we were kind of stuck at a barrier of not being able to cross something like 85% accuracy for a binary classification task. And well, we tried two approaches. My colleague tried to make a more complex model that will hopefully be able to capture the relations better between the data and the target. And I went into researching the data itself and seeing if there's anything else I can extract from there. To my surprise, I discovered that even though each person in the database had a unique identifier, some of the unique identifiers appeared more than once. Not only did they appear more than once, some of them were classified with different labels. This was a big surprise, and after researching it a bit more, I understood that what happened there was that some of the data was a bit stale and older, and just wasn't updated and overridden, but instead kind of stayed with all the new data. And dropping something like 30% of the records, which were the old records, actually improved the accuracy of our model by more than 10%, which was crazy at that time. So while as data scientists, we talk a lot on building the model, there's obviously also the other aspects of everything that has to do with the data, and also everything after the model is actually built. And I'm not sure that a big enough, well, this is more or less I guess you'll agree with me, the amount of time that we spend on each of these parts. And I'm not sure that we do really a comprehensive and effective and efficient enough work of validating it throughout. So let's talk about what should we validate. Well, the purpose of our validation is to make sure that we're trying to capture reality or represent the problem as it is. So we have the data, and we should ask ourselves, is it dirty? Is it relevant? How do its distributions behave? We have the method of actually splitting it when we come to train the model. So did we split the data properly? Did we use relevant features? Does it represent what we want to do? And we have the model, which we can check things like its performance, not only overall, but how is it performing in the worst places? Are there any subsegments of the data in which it may be reacting a bit differently? And also things like how will it react to changes in reality? So this is the general things of what are we looking at. But if we look at the actual types of issues that these models face, we see a wide variety. So we try to kind of group them into different categories of integrity and things that have to do with the methodology, model evaluation, data distribution, and many more. And as I said again, there isn't a magic solution for everything, but there is you can actually test for each of these things separately and verify that your model and data behaves the way you want to. So after this small teasers of the different problems, let's talk about when should we validate. Well, my short answer is as early as possible. So what does that mean? If we look at the pipeline of a machine learning model, once we already have the data, we can validate it and check its integrity, check any ambiguities or any dirty data problems. Once we've trained the model, we can both evaluate it, whether it's our initial model or already one of the final ones, and we can also look at their methodology and the splits that we've made. And well, after it's deployed, we would obviously want to monitor it. And like every machine learning project, this is usually an iterative process because sometimes we receive more data or we retrain the model, and obviously we would want to do it again for every relevant step. So since we're talking about doing it as early as possible, while in Deepchecks in production, we work also in monitoring systems, here we're going to talk only about the offline part, doing it as early as possible. So I'm going to present now a few of the ideas and things that we did in Deepchecks in the package itself. The thing is here mainly to talk about the different concepts of how can you check things, what do you want to check, and different ideas that we implemented. Of course, you can do it on any framework that you'd like or implement it in a different manner. This is, for me, a good way to demonstrate. And of course, as it's open source, I'd also love to encourage you to use it. So different checks that can and well, this is a few examples of checks that are currently implemented in the framework. So I gave before the example of the label ambiguity. So this is like one check of data integrity. Do we have similar samples or the same samples with different labels? Different things that have to do with distribution. Is there a drift between the data sets or between specific features? Things that have to do with the methodology. Maybe we have overfit in the boosting rounds or different types of leakage in the split. Evaluating your model, how does it behave on various subsegments of the data? Maybe it varies a lot. And comparing it to various baselines to know how is my model actually acting. And well, what you see here is the list of the checks that currently are implemented. The idea of the framework is to be very customizable and also enable each of you to implement your own checks that are relevant for your domain. So the general structure is we have the core logic of the checks, checking for each of these different issues. And in order to be able to incorporate them in a way that you don't have to necessarily evaluate them manually, each of them separately, we also recommend putting conditions on the different checks, which can either be like a pass-fail status or a warning that encourages you to check what happened there and is this result proper or not. And in order to do it in a more effective and efficient manner, a suite is just enables you to run lots of checks together. This is how it looks in Deepchecks itself. So each check has its display data and some results. Here we see like a summary table of all the conditions. And the test suite is essentially a list of checks, which is customizable. You can change the parameters, the conditions, and adapt it to your model and needs. So, well, when we talked about lots of different types of issues and problems and the fact that there is no specific school solution for validating your machine learning, but we believe that if you follow the following 3 steps, which is thinking about what are the problems that you want to validate or that are relevant. Sometimes there are various like more generic ones, and some are more related to your domains. Then implementing and customizing the relevant checks and running them every time that they're relevant. This will bring you a big way forward in validating your machine learning models. So one final note is I'd like to use this opportunity to both say thank you and also to encourage your feedback and suggestions. We feel that the incredible pace in which this package is being adopted is mainly thanks to the valuable feedback that we've been receiving from the community. And well, if this package is going to be used by everyone, which I hope it will be, we'll sure need a ton of help getting there. So please feel free to reach out if you have any ideas of contributions or general ideas, or even to let me know how you're using it, or really for anything else. So thank you for your time, and I wish you peaceful validations, positive test results, except for COVID-related ones. Thank you.